Welcome to our webinar today. It is Timely Anti-Money Laundering with AI. Thank you so much for joining us. We're really excited today to have our speaker, Ashraf Arthur. He's a security scientist at H2O. If at any point during his talk you have a question, feel free to write it in the Q&A box, and Ashraf will answer it either right away or at the end. There will be a Q&A section, segment. And yeah, without further ado, take it away, Ashraf.
Thanks, Jessica. I hope everybody out there can hear me, and welcome to the webinar, and thanks again for joining us. I know we've got people from different time zones, so good morning, good afternoon, and good evening. So just a brief headline as to what we're doing today. So today's talk is basically about how to use AI for detecting money laundering, and hopefully, if time permits, we will go ahead and showcase another use case, which talks beyond money laundering as well. As Jessica briefly introduced me, my name's Ashraf, and I basically work at H2O as a principal security scientist. My areas of research are in anomalies. I look at malicious behavior broadly. It could be anywhere from cybersecurity to electronic fraud, money laundering, or global migratory patterns as well. If you have any additional questions, after you've seen the slide, if there is a burning question that that I haven't answered in the short 1 hour that we are going to speak now, please feel free to email me, message me on any of these platforms. The last one, of course, is my email, and I would be happy to answer your question. Having said that, just want to thank all the people who've come by, and especially our customers who basically enable us to work on really cool problems, and definitely the AI for team, and the H2O team as well, and finally Patrick Hall, who was able to help me out with the slides. So having said that, let me just quickly go to our first question. How many of us attending today's webinar actually analyze data and build models? So essentially, how many of us are actually doing data science? And I can probably pause just for a moment, just to see what you guys are responding, or however it feels. And Jessica, please feel free to let me know, when the questions have been answered, so I can.
Yeah, we'll do. I'll give it like 10 more seconds.
Sure, thank you.
All right, I'll share those results.
Oh, great, okay. Oh, that's a pretty good number. So we've got about 50% of people who work with data, so that's pretty good. And actually, way more than that. I would probably say close to about 80% of people, work with data here. The rest, I'm guessing, probably this could be a primer, for you to get on it if that is something that you're interested in. If not, please feel free and see how we try to, or we're trying to, solve certain problems around the world using AI. Okay. So having said that, so this presentation, I'll just give you a quick overview of what the presentation is going to be, so that it makes it easy for you to, follow through. One of the things that we're going to introduce in the talk is an introduction to detecting false positives in money laundering alerts, and we do that using the feature recipes. So this webinar is focused on a small aspect of the larger picture that we are building, which is to basically detect money laundering itself. Now, detecting false positives is a big issue all over the world for many FIs. So this is something that we address as well as a part of our solution. And what will follow that is actually a very simple starter guide on building your own feature recipes. And as I go forward, I'll actually make it clear, how feature recipe adds value to what you're building. And that should probably help you, figure out if this is valuable. And then finally, if we have some amount of time, then I'll also try and show you, a peek into how we solve malicious domains problem in the field of cybersecurity as well, as that's another field that I'm very passionate about as well. So having said that, Another quick round of question. How many of you guys out there actually know about H2O.ai? Or is it the first time that you've heard of us?
All right, a few more seconds on this one.
Yeah.
And here are the results.
Oh, great. Okay. So that's quite a bit of people. Thank you. I think this is, we really appreciate the fact that, we are pretty well known. So 70% is not at all, a bad number. I mean, I would say it's fantastic. Thank you. So having said that, a quick introduction about what we do and who we are. So H2O.ai was founded in Silicon Valley, in 2012. We have been funded by, many famous investment groups and venture capitalists. One of the things that we are popularly known for is the open source machine learning platform that we have. And in the recent past, we are also known for Driverless AI, which is our flagship platform right now for doing automated machine learning. We have about 175 people who are experts across the company, who work in different ways to improve the product and to necessarily add value. We have a decent global footprint, in the Americas, in the Europes, and in Asia as well. Our industry footprint, and this, by the way, is our, largely primarily focused industrial footprint. We look at insurance, we look at manufacturing, we look at financial services, healthcare, retail, and ad tech. And I would like to point out that these are very high-level, groups. Under this, we look at many different domains as well. In insurance, we look at, customer churn, fraud, and optimum pricing as well. Similarly, in financial services, we look across the board, where we look at fraud as well, customer identification, profits, even for that matter, cybersecurity across the zone. So one of the things that we'll be talking about today is how we'll be building feature recipes for driverless AI for the problems that we're trying to solve. So based off that, I want to know how many of us actually know about driverless AI, or how many of you have actually used it?
A couple more seconds on this question.
Please, yes, yeah.
All right, here are the results.
Oh, great. Okay, that's a decent number as well. Thank you. So yeah, as I was saying briefly earlier, driverless AI is the flagship product that H2O has built. We of course continue to work on it to improve it. It is probably known as one of the best automated machine learning platforms. So yeah, that's great. Yeah. So driverless AI, very simply put, enables you to do, enables basically, it uses AI to enable you to, build your own AI for the solutions that you're trying to work on. And it's capable of delivering insights and interpretability as well. You get a plethora of visualizations and methods in which you can intuitively understand how your data is, how your model is, and prediction is. So if you haven't had a chance, please do go check it out on H2O.ai. You get a 21-day free trial to see how this works. Having said that, let's quickly jump into money laundering. So I'm guessing quite a few of you actually know what money laundering is across the field. It is essentially, the concealment of origins of illegally obtained money, typically by means of transfers involving foreign banks or legitimate businesses. So this is a very, well-constructed, definition for money laundering. But the idea is there are many different forms and ways and methods in which, money laundering is actually done. And essentially, this has been something that, financial institutions around the world have been fighting. But I think in the recent past, pressures have increased on the financial institutions to improve these things by central banks around the world. And the fact that AI has actually come in, around the same time has assisted financial institutions to actually take advantage of AI and build much better models as well. So, having said that, up till now, what was the best way that money laundering was being solved, right? Which begs the question: what were we doing till now to solve this problem? Well, the biggest method in which we were solving, the biggest means by which we were solving this problem was by using rules-based systems that detect instances of money laundering. Now, rules-based systems have actually been fantastic. I mean, a lot of things around the world that have worked up till now have been based off rules. But there are a few problems that actually comes with rule-based systems, and rule-based systems, especially when it comes to money laundering. The rule-based systems are actually slow in evolving. One of the things is that you need a very a lot of expertise to actually understand how to evolve these rules-based systems itself, which is one of the reasons they are much more slower than an ML-based model, for example. A lot of gaps exist, and gaps also bring in complexities in these rules, and these complexities and gaps could create situations which the financial institution has never looked at, or even the experts in the financial institutions have never foreseen. The third problem that actually comes by when we are going through this is a really high false positive rate. One of the things that I have assisted a lot of what I've done across the world is I've assisted a lot of financial institutions to try and reduce their high false positive rates. I have seen false positive rates from like 75% to about 99%. This, of course, as most of you might be thinking, would be attributed to the fact that these rules were not tuned. But even if you tune, there are because of the gaps and the complexities, the false positive rate doesn't necessarily increase beyond a certain level. So which is another problem as well. So why when we've got all these and we've got something that's some setup that is actually working in a sense, one of the reasons why this has become much more important or a lot more immediate need of addressing for the financial institutions is because of the fact that globally, there is a need to actually clamp down on money laundering much more than what it used to be. Central banks around Europe, Asia, and North America have actually pushed financial institutions to do a lot more in identifying more cases, in handling their true positives and so on. So which is one of the reasons financial institutions are also being very proactive, trying to adopt new technologies and so on to improve this model. Now, what we'll basically showcase for solving the AML problem is a pre-built model, a pre-built recipe that we have, and this is a pre-built feature recipe that we have designed, especially to reduce the false positives in AML. And this feature recipe actually covers a comprehensive set of features that we have seen, in the anti-money laundering case. Mind you, a lot of these features, although they're comprehensive, sometimes are customizable specifically to your financial institution. And that's one of the reasons we have also opened up the feature recipe process in driverless AI to help you build these nuanced feature recipes as well, that enables you to actually make much better features, much better models, and identify false positives in a much better way. Using these feature recipes, we also show the strength of driverless AI to build the best models possible, and to see how well these models are actually optimized. So one of the things that I do now, I probably quickly switch to a demo that I have. And 1 second. Thank you. Okay. So what we have here is a simple instance of H2O.ai that is actually running. So here we have a data set, which is an AML alert data set in this case. Let's quickly take a look at how the data set looks like, okay? Now, what we have here is the usual, information where you have account numbers, you have certain time, the time of, the transaction that has occurred, the line of business, the typology of the AML alert, target, and case. So for the non-initiated, there are, I think, most financial institutions around the world have either 2 or more than 2 levels of setting targets for anti-money laundering. So when you set an alert to a potential case, what you're suggesting is that this alert is actually possibly going to go into a suspicious activity, and which is why you set this as a case. And this usually is done by your first level investigators. Additionally, you could also have targets, which means that your second level or your third level, your senior investigators go ahead and evaluate the same alert, and then they identify whether this alert is actually something that needs to be sent as a suspicious activity. So that is where the difference between case and target happens. So case essentially is the first level, and target is the final level before it's actually sent to an FIU. And then, we have transactional identifications, where is this like a withdrawal or a deposit? We have information about, the banking prefixes. These are mostly banking information. We have transaction information as well. So in this data set that we have, there are quite a few features that we have identified are valuable, are valuable for assisting us in building a model to identify false positives. Now, very simply put, this data set is actually a combination of 3 different original data sources that have come together. And these 3 different data sources are, first, we have the transactional information. The following is we have the alert information itself, and then finally we have the KYC data, which essentially is customer information to help us assist who this person is. And what we basically do is we use this information, we eventually join this information together to form one flattened data set, and we send this through driverless AI to basically help us model. Now, mind you, driverless AI has its own set of native feature recipes or feature creation ability. But there are certain use cases, as in this case, we highlight that AML is a very specific use case. So this requires very nuanced set of features, that you would know or you understand, what are the kind of behaviors that you have to track. So which is one of the reasons we enable these recipes using driverless AI for these use cases as well. So this means that you can go ahead and build your features, upload it to driverless AI, and driverless AI will use it to build up a model that would serve your purposes. Okay, so as we've taken a look at the data, you can also, by the way, take a look at the data in a row format, which makes it really convenient, in case you want to analyze it. So once we've done this, what we do is, using driverless AI, we'll quickly say predict. And this is where we are trying to say, can you tell me whether this target that I decided is actually, indeed a target or not? And conveniently, the target column is also called target here. So which means that we can select target and map it. Okay. And now you have different dials here for accuracy, time, and interpretability. Now, accuracy tells you, how good the model is, how good do you want the model to be, or how much of a compromise can you have. Time is the amount of time that it takes to process the model, and interpretability is how simple or how complex, do you want the model to be. And that's basically the different measures that you can set. And your scorer is essentially what you're trying to score. Are you trying to optimize it to AUC, F 0.5, F1, log loss? Now, one of the things that we usually do is, while we're working with AML, I think most of the people across the board will know that there is a huge amount of risk that is involved. And that risk is purely dependent on your risk appetite, the financial institution's risk appetite. And the risk appetite is usually defined by how many false negatives actually occur when you're doing the classification. And false negatives, for the people who are not clear about, are those alerts, or technically are those rows, which are actually true positives, but because of the limitation of a model have been classified as negative, which means that these are actually cases that could have potentially been suspicious and sent to the government for further investigation. But because of how the model behaved, it got relegated to a negative, which means that you don't send it anymore. So, which is why when you choose F1, it helps you optimize it to reduce the false negatives as much as possible in this case. Okay, so that is F1. Now you could also choose log loss, which makes the entire error much more smoother. So which could help you with that, or you could just choose good old AUC. So in this case, we'll just choose AUC in this case. Okay. Next, when you want to actually get in a custom recipe, okay, when you want to bring in a custom recipe, what you do is you go up to expert settings, okay, and then you say upload a custom recipe. Okay, in this case, I have my AML alert false positive reduction, okay, runner as my code. Now, once I ingest that Python code, right, I am able to see all the transformers or all the feature engineering that I want to do in the recipe part. So let me highlight this for you for a second, okay? So if you see, most of the features that we have built for AML are all highlighted as AML, okay? Which makes it easy for us to identify, and these are all the set of features that we have. There is, what it also does is, because you've brought in the specific features, you have also disabled the native feature engineering that you would want driverless AI to do as well. So let me quickly disable the recipes for another use case, which is malicious domains as well. And I'll quickly take you through the AML recipe. Okay. By the way, if you have any questions as we are going ahead, please do feel free to drop it into the window so that I can answer it as quickly as I'm done with this. Okay. So now, once you've enabled the recipes, once you've enabled the features of the recipes, now what you have is you have all these feature engineering or these recipes, these features that have come out of your recipes listed out here. So these are the ones that are actually going to be tried on your data set. Now, all we have to do is just launch the experiment and off we go, okay? So now, once we, let's quickly get to a point where we get some information, and I'll also pause right here just for a couple of minutes to see if there are any questions, and I can take some while the experiment is running. All right, so we have an anonymous attendee who says they have implemented a certain product in their system already, but they are interested to use the false positive reduction recipe and integrate it into their case management system. Yes, you can actually integrate that in your pipeline. One of the things that we also provide as a part of the driverless AI system is an endpoint which you can automatically deploy into your existing pipeline. So this endpoint could be of three forms. One, it could be purely out of Python, which would be like a Python pickle, or we could even give you like a REST endpoint, which means that you could call up driverless AI and say, can you host this for me? And it will just host this as a REST endpoint, and you can just call it as and when you need the results of a certain alert. The other two methods are something based off the Mojo method, which means that these are super light, either Java or C++ objects that you can deploy with very minimal library requirement, which will assist you in classifying this as well. So there are essentially multiple ways in which you can deploy it. And that makes it easy for you as well. If you want it super simple, you can just go ahead and try and use driverless AI itself to deploy you an endpoint, and you can integrate that in your pipeline. Thank you. Spark is so. I have another question where I think the person is asking me whether we use Spark in our AI ML workflow, or you have your own framework. So in the driverless AI setup, we do not use Spark, but the ways in which we deploy the end model, you can definitely use Spark if that is a part of your pipeline. I think we had a couple of questions out there. So what we also see now is, we've been building the model, and essentially, if you look at it, you see that, here there are multiple iterations of different models that are going on, okay, on the left-hand bottom of your screen, which is telling you what is the current best optimized value for this use case. Okay, and then in the middle, you're also seeing the variable importance, which is telling you what are the different features that have actually added value to your model. Now, while I was hovering over this, you probably saw that the variable importance actually shifted. Now, the reason that is happening is on the left-hand side, you actually see a blinking line. That means that there are multiple models that are being tested at any given point in time. Based off those different models outcomes, these variable importance change. And so based off that, it'll tell you, what is valuable or what variable is not valuable anymore. And if you come to the right-hand extreme side of it, it'll tell you, how best is your model optimized. So here you can actually see, we are using the AUC, and basically this is telling you how best your model is optimized. You could also look at what is your best F1, your best ACC, or your best MCC as well. So you could look at any of the scores that you want. We very conveniently highlight this for you as well. And so this is essentially how our experimental setup is, okay? What I will also do, if there are no other questions, with regard to how the experiment is being run, once it finishes, we can actually come back and, just show you what are the different ways. I'll basically highlight and tell you what are the different ways in which you can deploy. If there are no other questions, I'll actually quickly switch to how you could build a very simple, your own recipe, for driverless AI and take it forward. Actually, we can probably wait because the experiment is completing soon. So feel free to use this time to ask any more questions if there are. If not, totally fine. Okay. I think this might take a couple more minutes, so I'll probably switch back to the slides. Okay. So I want to ask a next question, while this is running. How many of you have actually tried building a recipe, in the audience? Or even tried playing around with the fact that we opened up the feature recipe space.
Give this one about 10 more seconds.
Sure, please. And folks, as I said earlier, please feel free to, drop your questions. If it's a burning question, I'd be more than glad to answer it right away. So please, do not bother about, the fact that it'll be in the middle of the talk.
All right, there are the results for that one.
Oh, okay. Yeah, so, all right, this is fantastic. So this is a great opportunity for you to understand, how to go about building a very simple recipe. And in this case, I will actually highlight, building a recipe for, having a log transformation, which I know most of us know is like one of the most simplest transformations that we build, okay? So let me just quickly hit full screen, okay, just to be there. And what driverless AI, so the way driverless AI extends is it has different it has different ways in which it's extended the modeling capabilities. One of the ways it has extended the feature engineering capabilities is building out, a class called custom transformers. And this class actually helps you extend the features to whatever custom features that you want. And you have to understand the impetus for us to do this. Although we are good at what we do, we can build a comprehensive set of features. But we also know that all our customers are actually experts in the field that they work in, which means that you automatically have a leg up, over us in building these amazing custom features. And and that essentially was the impetus for us to make, the feature engineering aspect open and to bring you in to actually build these features. Now, one could think, why then we need to do this? I mean, while the usual workflow of feature engineering is valuable anyway. Now, what we did is that while we opened up the feature engineering aspect, we made it in such a way that it is heavily parameterized, and all you have to do is provide a few things to this recipe, and which is why we actually call it a recipe, okay? So, when you add the ingredients, things just make it very easy, and you can actually get your own recipe done. So having said that, so what a driverless AI opens us up to is a class called custom transformer. And essentially, we build a transformer using this custom transformer class, okay? And in this case, as I said earlier, we are building a log transformer, so which is what we'll go ahead and build, okay? And this class has a few quick things that it needs when it's going forward, okay? There are parameters that need to be provided to these class. And I'll actually walk you through these things so that you know exactly what you're supposed to add and how they actually come up to value, okay? And these parameters are very specific to the kind of recipe that you're building. By the way, mind you, these parameters are a really small list. They are not a very big, list that you might even forget. It's really small. You can quickly, set them up, and most of them are usually, just booleans. So it's very easy for you to set it up. And we also have 4 different methods that primarily handle your feature engineering as well. And as a part of this building process, I'll also take you through these 4 different methods just to make it easy for you to understand, how you can go about this. Okay, so one of the first things that we have is this is basically the interestingly, this is the basic parameters that we actually add for our transformers. Okay, what we are looking for here is so let me list it out first. It's regression, binary, and multiclass. All we are saying when we are listing these 3 things out is we are saying, does your transformer or does your recipe apply to a data science problem which might require regression or which might require, binary classification or a multi-class classification. It's very simple. So depending on what you're addressing, if you set that to, true or false, then it'll automatically become, this will automatically get registered in driverless AI, and driverless AI will know when to apply and when not to apply your custom transformer. A very simple set of, a very basic set of features, okay? Sorry, a very basic set of parameters. Now, having said that, what we have is also an additional, by the way, if you just answer those three, your recipe will work perfectly fine and it can go forward as well. There will never be a failure. But there are additional parameters as well that you can bring in, where you can say, is the output going to be numeric? Okay, and is this feature actually reproducible? Now, let me explain that very quickly. Okay, so the numerical output basically tells driverless AI that what you're outputting is actually numeric in nature. Okay, meaning that the output of the transformer. So driverless AI has a very optimized and a quick way of handling these things. So which is one of the reasons we would need this inputs as well. Quick interruption. I actually have a question that has come through. I'll probably do this right after I'm done with the recipes. I hope the speakers, I hope the person who's asking the question is all right about it. Thank you. So then the next question is this class reproducible? Now, what we're doing with this is we are checking whether we can use this class, in production and, in training and production and in training and in production the same way. Okay, that is one of the things that it's actually doing. Now, the other thing is there could be some modules that are not required for this transformer, or there are certain modules that you need to exclude for this transformer. Okay, and that can be highlighted based off this exclude module class. Actually, that's module, my apologies. And then modules needed by name, which will define the exact kind of module that you require. Okay, so these are your basic set of parameters that you put in to the recipes, and that's about it. Now, the next thing that you do, so once we're done with these parameters, we'll actually switch to the methods. So the first method that comes up is something called as a do acceptance test, okay? And all this test is doing, very simply, it is telling driverless AI that you can actually test this recipe before you apply it. That's all it is doing. In case you have situations, where you do not need this test, then you can always disable this. But all this is doing is, it is like a sanity check that the driverless AI does much before the recipe goes in. So it would be great if you keep this on. But if for some reason you find, a situation where it's not useful, then by all means, please. So the next thing that it actually switches to is, once we've done the acceptance test, then there are a default set of properties that you need to give driverless AI, okay? So you have to understand that this feature recipe that you have needs a set of input columns, and then it gives you an output column, okay? So what are the types of input columns that you actually need? That is something that you need to define. Right? So the way you define that is you use another method called get default properties, and you define the type of input columns that this recipe can actually take. This could be numeric. I'll actually take you through the different kinds of column types that you can take. In this example, what we have highlighted is the column type is ingesting something called as numeric. And the minimum and the maximum columns actually tell you how many columns it needs at a minimum and how many columns it can take at a maximum, okay? And the relative importance is actually a pretty cool thing. So what relative importance actually does is it basically tells driverless AI how important this feature is. Now, just to see if your feature is actually being applied, you can boost this up to 1,000, okay? If you feel that you do not want to see this feature, you can actually bring it down. You just have to make sure that it is on the positive side of values, that's all. So it's a very simple parametric property setup, and you're good to go. So this is a second method where you're basically saying the kind of columns that driverless AI's recipes can actually take in, okay? Feature recipes can take in. So as I promised, the input data types that are supported, for the ingestion. Now, if you say all, then, all types of columns will be actually included. okay, which will be accepted. If you say any, then literally any kind can actually be brought in as well. Now, you could also have numeric, as I had suggested earlier in the example. You could also have categorical. You could actually have numerical and categorical, is something that we actually see in our option E. You could also have date and time, okay? You could have merely date. You could have text, and you could have a time column. You could actually specify a time column. Now, these are the 9 different options that you have that you can actually choose when you're building your recipe. And it's as simple as that. You do not need any other types to do the ingestion, merely these 9 types, okay? Once you're done with this, you define how many columns, how many of the minimum columns that you need. Let me take back you to that slide. How many of the minimum columns that you need, the maximum columns that you need, and your relative importance, and then you're good to go. Okay. Now, so mind you, I promised you that there are 4 methods that are there as a part of the recipe. Now we have completed 2, which is the acceptance test and the default properties. Now let's get to the third one, which is the meat of these feature recipes. So what we do here is essentially the fit function. Now the fit function is what is going to be applied when you're running, when you're basically running the recipe on while training. So all you do is you basically get the data frame in, and in this case, if you remember, we are actually doing a log transformation, okay? So all we're doing here is essentially a log transformation and sending that data back. Now the fit function is very specifically used when you are training the dataset, okay? So, and that essentially is what it's used for. Now, similarly, once the fit is done, the 4th method that I'm talking about is basically the transform. And the transform is the function that gets applied when the dataset is in production. Now, there is a very fine reason why we have separated this, because there are different approaches that you could use. It basically gives you the flexibility of approaching, the fit and the transform in 2 different ways, and which is one of the reasons why this flexibility exists as a part of the feature recipe, okay? So essentially, what we saw here is a bunch of parameters, okay? A very small bunch of parameters, which is very easy to define, and 4 different functions for you to get off the ground and, build your own recipe, okay? It is a very simple process that you can use. Having done that, now, let me pause here for 1 second to see if there are any questions, and I'll answer the question that the gentleman had earlier, okay? All right, so one of the questions that I actually have from a gentleman named Murali Shashank out here is if we are working in insurance domains as well. Yes, we do work in insurance domain, but that is not a part of the presentation that we're doing today. Today is purely specified on AML, and essentially, if we have enough time, a sneak peek into how do we do malicious domains as well. But I think we'll keep you posted. If you can get in touch with us, we'll keep you posted about any other future, insurance specific recipes that we are building, if that's all right. Thank you. So having showcased this, let me quickly jump to another use case, okay, which I promised you. So before we go there, if you actually see, we have built a model here, okay? It's a very simple model. We have had a decent scoring level. We have had a variable importance, which is good here as well. And then we have, the different interpretations. Basically, if you want, you can go ahead and interpret the model, to see how good your model is. If you want, you can also diagnose the model. You can run other data sets. If you want, you can also download, the experiment summary to understand how this model was done. And you can also, use the Mojo scoring pipeline in this case. So these are the 2 scoring pipelines that I was talking to you earlier about, where you could use a Python scoring pipeline, or you could use a Mojo scoring pipeline as well to deploy, okay? So these are the different methods that you can use to very quickly deploy, your models out in the open to start using them. It's as simple as that. So having said this, I shall take you through another very simple data set. I know we are pretty decent on time. So what we see here is a very simple data set, which is called malicious domains. One of the big problems that we have basically in the field of cybersecurity is, where you have multiple domains which are, machine generated. And what we use when we have machine generated is that these domains are used, for all malicious purposes. Okay, and in this case, if you look at it, we have domains that look very interesting, and we identify them as generated or non-generated. Very simple as that. So all we do is we quickly take them through, and we say predict, very similar to the approach, and we say type, okay, because that is what we're trying to predict here. And then we go back to the expert settings, and here we've already preloaded the recipes. Just make sure we uncheck all, and in this case, when we say enable custom, we disable all the AML specific transformers. It's as simple as that, okay? Give me 1 second, I should be done with this. All right, we're good now. So let's just go ahead and launch the experiment. So what essentially this will tell us is how good of a model we can build based off the data set that we have. And having said that, so I have a question from Angel Garcia. How does driverless AI score interpretability? Could you be a bit more clear on that when you say score interpretability? I mean, are you trying to say how are interpretability models or something else that you're referring to? Angel, I'm sorry, did you hear my question? Sorry. Oh, okay. Yeah. All right, let me take you back through that then. Fantastic, okay. So, sorry, thanks, Solomon. I think Angel's question was basically, what's the idea with the interpretability knob? Well, one of the things that actually happens is there are different modeling techniques that driverless AI actually uses to build models. And these models could be, blending, stacking, any of these mechanisms which could build like complex models, which are pipelined. So when you actually ask for an interpretable model, basically what you're asking for is essentially a simple model. And I understand why that could be important. There are lots of use cases, especially in AML and fraud itself, which involve regulators, where they could say, you know what? I do not want these complex models. I do not want any of these things done. And you could give me a very simple, you need to give me a very simple model is something that could be an ask of the day. So in that case, what you do is, let me quickly take you back here as well. So let's say you say predict, okay? And we're running the AML experiment again. And let's say we select the target, okay? I won't do any changes, I'll just take you through this. And you could set the interpretability to be really high. If you actually look at it, the different kinds of feature engineering that driverless AI does and the amount of models that it tries reduces quite a bit. And that is because what you've told driverless AI essentially is that, driverless AI, please give me a model that I am okay with to compromise a bit on the accuracy of it, but that has to be much more explainable when I take it to, let's say, a regulator. And when you said that, you actually get a much more simplistic model, which is much more explainable. And that is done by high interpretability. Mind you, high interpretability could also take a decent amount of time, or depending on how complex your data set is. But that's essentially not the fundamental idea here. Interpretability is purely to make the model as simple as possible. Okay, so the next question, you're welcome, Angel. So the next question I have is from an anonymous attendee is, did you compare benchmark with any other false positive reduction solutions for AML? What is the advantage of H2O and driverless over custom AML solutions? Okay, that is actually a fantastic question. So let me quickly take you, okay. So one of the things that we have done is we have compared, how driverless AI runs with other custom solutions, and there are a lot more custom solutions that are more, service solutions, not product solutions that we have compared to, and we have definitely had a really good standing when we compare ourselves to that. But the essence of what we are doing is about the product that we use and how do we use the product to actually deliver these results. Now, when you have someone who is customizing these false positives, basically building you custom models to do these false positive reductions, what you're doing is you are focusing on, give me 1 second, okay? You are actually focusing on trying to figure out how to reduce these alerts, right? But in this case, what driverless AI is doing is it is automating that process for you to build the best model possible and the best set of features to use for that. So some of the advantages of building these features using driverless AI is you have a preset of parameters. It is very easy for you to enter these parameters, and you could have your model within minutes, if not like within an hour or so. There are preset methods, which means that your job is very well defined about what you need to input and what you will be getting out. The effort is minimized, so which leads to minimization of the time that you spend on your problem. And one of the biggest advantages is that because this is a build only once, so once you build the recipe, it automatically gets transferred to the production pipeline as well. And DAI itself runs multiple models using multiple combinations of your features to actually add value, and give you a much better model. And all these requirements and all the mechanics are actually handled by driverless AI internally. So literally all you have to provide is a recipe that eventually goes into driverless AI and gives you the best possible model for the job that you're doing. So having said that, let me quickly skip to the next question. Okay. Can you also, also show the output of interpretability of a model? I can, but I think, give me a quick second. Can we specify that we need a linear model, say only logistic with limited number of variables? Yes. So what you can do is, let me quickly switch here. So one of the things that you could also do is, if you need a linear model, you could switch back to expert settings and you can say compliant. So once you say compliant, you actually get a linear model out here. So if you see, so if you do not want any other combinations of models, then you would basically see a very compliant model out here that would give you, the model would be very specific with GLM. You can also specify the set of features that needs to be used. And it could be as simple as just running another GLM model automated as well. The one other thing that I would also want to show is you can use another aspect as well in driverless AI, which is called projects. Okay, and in the projects you can say, let's take it through this. You can create a project and you can compare default experiments that you run on default feature sets, experiments that you run on custom feature sets, models that you have built with complicated, complex modeling pipelines and compliant pipelines as well. And you can compare how the scores are. And based off that, you can basically present, what best is a solution for your organization as well, which it essentially helps you take a call about, how best to organize what you work on. Okay. Having said that, let me see if I can have an experiment. I think there was a question about, sorry, the question was, can you also show the output of the interpretability of a model? Okay. So I think Ashok is having a question about the interpretability. I'll just try and see if I can finish the model, and then I'll open up the interpretability for you. Okay. Meanwhile, there is a question which is, what kind of unsupervised learning process can be implemented? What about things like anomaly detection? So one of the ways that we are actually working with driverless AI is to actually use, so your features can actually bring in unsupervised approaches as well as anomaly detection as well. You can bring outputs of these, submodules as a part of your feature and put them back into the original data set to show you how good, to basically show you how good the model is when let's say you're trying to identify it. But primarily, building unsupervised itself is not possible in this case, but you can always bring in outputs of unsupervised modeling into the system. Okay, let me quickly, I think this model is probably still running. So we've talked about this. What I would also want to pause for a quick second is, I'm sorry, I think we're running out of time. So in case you want to look further into, how to build these recipes yourself, here is the GitHub link, okay? I would be happy to share this. I'm going to share this online as well. So you're more than welcome to, utilize the same approaches. And as always, please forward your questions to us in case you have any more. Having said that, I would quickly like to say thank you and see if this, okay, there's, interpretability is one. Let me see if the model is done in this case. Yeah. Sorry about this. Yeah. Let me see if there's another. This, okay. It's this one, sorry. Yeah, if there are any other questions, if not, I'll actually pause. I think I'm trying to get this experiment running to showcase the person if, we can show this model out. Okay, this might take much more time. Ashok, is it possible that, I can like send you more information about this? Maybe that'll help just in the interest of time. Yes. I was trying to see if I can get this experiment completed, but it looks like it'll take time. So I might have to take, the PDPs and the Shapleys just right after, if that's okay. Okay. Thanks, guys. Jessica, I'll probably give the control back to you if.
Sorry?
No, I just give the control back to you in case, you have some closing remarks or something.
Yeah, sure. Okay, you're all set. Well, yeah. Thank you so much, Ashrit, for giving us this great presentation. And thank you everyone for listening. Be sure to check out AI for Healthcare and H2O World New York, which are both conferences coming up. And thank you again. Everybody enjoy the rest of your day.